Hello everyone. I guess the most attendee is our Arabics from Egypt. So for, my part will be in Arabic. ازيكم يا جماعة؟ أنا أحمد سعيد ليدر تيم سواجن. أحب بس أرحب باشمهندس علي بوجوده هنا النهاردة. باشمهندس علي هيقدم لكم سيشن كويسة جدا جدا بعنوان الادفانسد موديلنج والانجينيرنج مانيفاكتشرنج. نتكلم عن التصميمات او ازاي نصمم بطريقه احترافيه اكتر. باشمهندس علي غير انه سوليد ورك تشامبيون وسيرتيفايد اكسبيرت وحصل 14 شهاده. هو مش اول مره يدي سيشن. باشمهندس علي عنده خبره واسعه في انه يعطي سيشنز. السيشن ديت مهمه جدا واتمنى تستفادوا منه وما تضيعوش فرصه زي ديت. I will leave the mic with engineer Ali for continuing the session. I'm welcoming you in Mansoura Swagan. It's a great pleasure to having you with us today. Thank you, and you can start when you're ready.
Thank you so much, Yusuf. And I really appreciate you invite me today at this session. Please give me a couple of minutes and I am ready to present the session.
Yeah, sure, no problem.
Hello, Yusuf. Can you please ensure if the screen is visible to you and my voice is clear as well?
Yes, good, and I can see the screen as well.
Yeah, perfect. So I think we are good to go with the session right now, right? So let me get my pointer first. Yeah. So today's first of all, I would like to thank the Mansoura SolidWorks user group network and Ahmed Said for inviting me for today's session on the topic of beyond basics, advanced SolidWorks modeling for engineering and manufacturing. While on the top of the title we have utilized beyond basics, so we will be covering some advanced stuff related to manufacturing, and maybe in today's session we will not be very much on SolidWorks, but yes, we will be creating a balance between some content and the SolidWorks as well. So before starting the session, let me introduce myself. My name is Ali Haider. I am the founder of the Digitize Studio, and I have been honored with the SolidWorks Champions title and a certified SolidWorks expert, as well as I am also providing services on Upwork as a top-rated mechanical design engineer. I have been also honored to get 14 plus international certifications of SolidWorks, and that it's pretty much. And for the today's agenda of the presentation, we will be talking about the product life cycle, how the products from the start till the end is going to be prepared or maybe invented, and then moving towards some design for injection molding thing, and we will be understanding the injection molding and some best practices and the key terms to understand. And then we are going to discuss about the real world assembly modeling, which is basically how we are going to prepare our model based on the real world application, what something that we usually confront in our real life, we need to use that memory in order to imaginate our CAD environment world, so that we can create a design which is easy to manufacture, and also the design that is easy to be modified in future. So moving towards some key terms about the multi-body part, then top-down assemblies and bottom-up assemblies, we will be discussing which method is important, and how we need to how we need to proceed in specific case that we maybe face. And in the next, we will be discussing about some parametric and configurable designs. Maybe we need to create some adjustments into our design based on some references with the help of equations. And also maybe we want to create some number of configurations, like for example, if I want to create a cube, and then I need multiple sizes of the cube, so we will be discussing configurations and some view states. And at the end, as usual in my all presentation, I used to add the career opportunities, so that everyone could get the opportunities if they are being expert on SolidWorks, how they can get help to earn, and also to grow in their career. So starting with the product life cycle, we have five different major divisions in the product design and development industry. So starting with the ideation and brainstorming stage, in this stage we usually confront to our maybe customer, maybe the product that we are going to invent and move into the market. First of all, we need to study about the requirements, that what are our goals, and in what direction we are going to move, and what should be the rough sketches and ideas for that design to be ready, that will be went into the manufacturing, and then ultimately into the market. So at the very first stage, we need to identify what are the problems, what are the parameters, and what are the basic sketches for the product that we are going to design. And in the second stage, we usually prepare a concept design, which is usually a 3D concept design. And we don't really put focus on the design for manufacturing, but we just understand if we are gonna convert our sketches into a 3D model, how it looks like. So we are convert basically creating some 3D shapes, and without focusing how we are going to manufacture it. So this is basically a concept design. Maybe we can convert into a render as well to visualize how it will look like in a 3D environment. Then once we are done with the concept design, then we will move forward to our third stage, which is design for prototyping. So prototyping is an essential stage. And if I say, these first three steps are very critical in saving your cost and time. And if you put a lot of time into these three stages, then you can minimize your design for manufacturing and the production stage very much time. You can also save your resources as well. So in the third stage, we usually convert our concept design into a design that will be ready for the prototyping. For example, if we are going to utilize 3D printing for understanding that if this is our concept design and we want to develop it, and see what if we have it in a real world, then is it worth it for us, or there will be some causes, there will be some problems in this design. Then in the design for prototyping stage, we will optimize our concept design, and we will iterate this process. For example, we have prepare our first prototype, we will test it out, and if there is some mistakes, if there is some issues, we will resolve that in the CAD. And in our second prototype, we will again test if the problem is still exists or not. So this is an iterative process. Once we are good to, with the design in the prototyping stage and our prototype is ready and working perfectly, then we will move forward to our design for manufacturing. And in the design for manufacturing stage, we basically use the injection molding technique, in which we convert our design to optimize for the induction, for the production, in which we want to manufacture hundreds, thousands, 5,000, maybe 10,000 and 50,000 parts in a row with the help of automating production lines. So for that, we need to prepare the mold of the design. So we need to convert our design for prototyping into design for manufacturing, which is to optimize our design for preparing the mold. So in the production line setups, once we are done with the creation of the mold, then everything will be automatic based on the production line setup. Then at this stage our product is ready, but at the final stage we have product visualization stage, where we need to market our product. We want to put our product into the market based on the 3D models. And what practice in today's area we focus on, what we do, the design is in the production stage, but at the same time we start to market our product, so that we can get some pre-market orders from the customers. So for that we create 3D renders, we create animations, and we maybe use design for prototyping in this marketing stage as well. So we have all these five stages as a different categories, and the engineers do have positions in all these five stages. So in this way, we've from moving from ideation to concept design and preparing a testable design for prototype, and moving into a production line, and then visualizing our product, and moving into the market. Moving towards the injection molding. So at the very first stage, what we are going to understand is how injection molding works basically. So on the left side you can see we have the nozzle, the charge. So in the blue color you can see we have the charge, which is the material that can be in the form of pellets, in the form of small granules. So we usually pour it from here on the top, and under that we have a nozzle. And here we usually have the hot melting nozzle. So heaters are applied here that converts the granules into a molten plastic. So that molten plastic from the nozzle enter into the sprue. The sprue is basically the pathway that directs the metal into the gate, the runner. And the runner is not the main part, it is just for the movement of the plastic into the main body that we are desired of. And in this assembly we have this blue portion right here and here. These are two components that we want to we want as a product for the final product. But in the middle, these connections are called runner. The runner is basically used to flow the molten metal into the cavity. And where we have the connection between our part and the runner, those are called gates. And these gates are the points that we after removing our part from the injection mold, what we do, we cut from at this location. These are some small points, we cut them out, and after that our part will be ready. And on the right side you can see we have a core side and a cavity side. What the core side do is, yeah, so what the core side do is it can move in the upward direction, and the cavity will move in the downward direction. So in the next slide we will be covering some important terms. For that you need to understand that once we have our part in the middle of core and cavity, then we need to open our mold. This is the mold's core side, it will slide in the upward direction. And this is the cavity side, it will slide down. And these two here are the for creating the cavity inside our part. these are some sliders maybe, but we usually use sliders in this direction, maybe in in maybe perpendicular direction or at an angle to these normal positions. This is positive side. If we consider this positive, then it will be a negative side, and all other like all directions other than this will be acting as a slider. So in the next slide we have some key terms and best practices that we want to understand. First of all, there are some drafts. Draft is basically can be positive, can be negative. Right here you can see it can be positive if we want it in the upward direction, and can be negative if for the cavity side. And then we have ribs, and ribs are basically for the structures that we want in our model, in order to have where we have the cavities, because for the for the injection mold we cannot have a solid model. Let me go to my SolidWorks screen and show you what does mean by solid model, and what does mean by cavity. For example, in injection molding I have created this rectangle, and I am extruding it up in 10 mm, and click OK. So this is a solid model, because in injection molding the minimum size of the wall will be 3 mm. This is 10 mm. So in order to have this solid face, what we can do is we can cut the part from the bottom, put it offset of 3 mm, reverse the direction, and then cut it by specifying the offset from this face as well, and the offset value will be 3 mm. So here you can see we have now the uniform thickness in a way that this wall thickness is 3 mm and the bottom is 3 mm. So this is our part ready for the injection molding. But the issue in here is that if this is a very big plate, and I want to make sure that it is basically strong enough that it could withdraw the pressure applied on this face. So for that case we create ribs on this structure. So in order to create the ribs I will select this top place. You cannot select this place for creating the ribs. You have to create select the plane from which you want to draw ribs. I am selecting this plane, creating a sketch. I'm just going with the rough, the ribs. I am giving it a linear pattern, clicking OK, and then in the features tab you will find ribs. If I click on it, you can see the preview of the ribs as well. Here we have these three categories. One is on one side of the line. You can see we have a black line in the middle and blue line on the one side, which means this is our main black line, and ribs will be created on one side of this of it. If I click on the center, then it will create a rib on by having half on the right side and half on the left side. So for example, if I click on 1 mm, then then here you can see we have zero point 0.5 on the right and zero point 0.5 on the left side. Similarly, uh, here it will be on the opposite side. So here we have the extrusion direction. Here you can see the extrusion direction in the vertical, but we don't need it like this. What we want, the thickness, like here, and specify the thickness of the ribs, and click on OK. The sketch must have only one open profile. It means that we have our sketch in here, but we want to close it in the downward direction. So we have to change the the direction, the extrusion direction, specify the mid plane, and click on OK. I think there is some issues. Let me resolve it later, because I think I am getting something mixed up. Let me get back to the slides. Which you have understand the way that how the ribs are important for our structure. So we need to create the ribs in order to make it more strong. In the next slide you can see we have the following ribs in here. So the the purpose of this point is, in order to have our solid as a uniform wall thickness of 3 mm, but we also want to keep the strength and don't want to have compromise on it. What we do, we create ribs on the structure, and this part will be ready for injection molding. And then we have wall thickness. It must be uniform. As I talked earlier, we must have a uniform wall thickness throughout our model of the plastic part in order to get our part ready for the injection molding. And then for the fillets, we must have to ensure that the fillets on all the corners will be applied, because we want smooth edges. The sharp edges will hinder in the smooth flow of the molten metal into the molds. And the gating, from here I have specified the gates right here. So what you have to do is, it leaves marks on the surface. So the optimized design for injection molding is one in which the gates will be at the places where we have the parting line, or at the faces that are hidden and are not in front of the on the main feature of the part, so that it cannot destroy the appearance of our part. So we need to have our gates on the parting lines, or have our gates on the hidden faces of the part. And then we have parting line. By parting line we means, this is the parting line that separates the core and the cavity. This is called the parting line. This horizontal and the vertical line and downwards, this is the parting line. So the parting line again should be on the edges, so that there will be, when there is a misplacement in here, right, this above line, this top line and the bottom line will not be perfectly aligned with each other when we have actual manufacturing. So to avoid that this marks a straight line on the plastic part, what we do, we always create parting line on the edges. Like here you can see we have the edge, and we have exactly the parting line on the edge. So that way, if we have the line on the edge, it will not be a fault in the surface, and it will not destroy the appearance of our model. Then we have ejection marks as well. When we have our part in our the production line, and then we have some ejection pins there. When we have, you can see here, we have added our molten plastic into it. And at the end stage, like here you can see, one of the part will be moving, like maybe core can move, maybe cavity can move, and one of the part will be fixed. And the part that is fixed, that part will have these ejection pins. These are what ejection pins can do. When we move the core side away from here, the part and the cavity side will remain in place, and the ejection pins will move, push our part out of the mold. And then the process repeats. The molten metal again enters into the mold. So this way the production line works. So the ejection pin hits the part with some force, while the part will be heated up. So it will left some marks on the surface of the part. So what you have to do is, you need to put the ejection pins on the faces that are hidden. And in real time you also have seen some plastic parts on the inner side of those plastic parts, maybe for any enclosure. On the inner side of those plastic parts you will see some marking lines, marking spots. Those are for injection pins. So that's why you have to avoid that thing in order to clear the draft angles as well. So first of all, here we have our part that have no drafts, right? So in order to pull for example, if I want to manufacture this thing, we have a we will be having a core on the top and the cavity on the bottom. This part will go upward and the bottom part will go downwards. What happens here? So from here, when you try to extract the core side in the upward direction, this is a proper 90-degree angle. So the core and the part will stay in contact with each other. When I will forcefully move the core in the upward direction, what it will do, it will slide on the surface and leave some marks on these on the surface of the part. That is that is not feasible for us to have a good injection molded part. And similarly, when we move push the ejection pins and push this part with the help of injection pins, then the outer face also cause surface friction between the cavity side, then the part will have some marks on it. So we should avoid that thing. On the left side, you can see when I will try to pull the cavity core in the upward direction, you can see the part is inclined in the inner direction. So obviously we are not able to draw it in the upward direction. So this is the negative draft and it is in the wrong direction. And similarly in the bottom direction, when we have our the cavity like here outside, like here, when I try to pull it downwards, this position will not let him come out of it, and the part cannot come out of the mold itself. So we need to take care for the draft angles. Although the value is very small, draft angles, maximum draft angle usually is zero point 0.5 degrees, and we can reduce that draft angle as well. But sorry, not maximum, it's minimum is zero point 0.5 degrees. Every part that is ready for the injection molding should have a draft angle of zero point 0.5. And the ideal condition is when we have the core in the upward direction, then we need to provide a positive draft angle like this one. So now we can move our part easily in the upward direction and there will be no contact between the walls and there will be no marks. And similarly, the cavity can be easily come out in the opposite direction, right? Like in the downward direction, like this. So it can easily move out. So this is why draft angles are really important. And for the undercuts, these are the undercuts. So here, if you have the draft sorry, if you have the cavity at the bottom side, it is an isometric view, so cavity can slide downward, no issues. But if we want to drag the core side in the upward direction, the material under this section will keep it locked, so it will not able to move outwards. So for that purpose, what we do, we create a section at here. We will add this section into our cavity side. We will create the cavity right here, and we have a solid rod coming up till this surface, like here. And in this way, everything will slide downward and the rest from this location can slide upward direction. So we must have to keep this thing in mind. In order, if we should avoid the undercuts, but if we want just like this, we want to have our snap fit joint, then obviously we need to consider that we have to give some room here in order to provide the support from the down direction, not from the upward direction. So we must avoid the undercuts as well. Now moving forward with the real world applications, we have some, first of all, the design intent. And here, for the design intent, we mean in order to start the model, maybe from the concept, I mean from the very first stage, you must ensure that what are the parameters that may be changed in future. So you have to understand those at the very first stage, and you also have to understand that what are the parts of our design that are dependent on each other. So at the very first stage, you have to understand what are the parts that are dependent on each other, what are the dimensions that maybe in future we can have to modify, maybe the wall thickness, and also that what features should be, that must be modifiable in future. So this is the design intent. So in this way, you have to organize your feature tree in a way that you have to apply the the feature at the very first stage, and then we will move with the same intent up till that we have our final design. And a perfect design intent CAD model is the one that if you want to make some modification into the design, you just need to modify one thing and everything will be modified accordingly. But the difficult part here is when we have a very complex design and we design that based on, like, with reference from another part. So in future, maybe the designer change for that project, maybe you forget that which part is depending upon which part. So the child feature and the main feature, you maybe forget that thing. So you must have to use the way that cannot destroy the rest of the component. So we have, first of all, the multi-body part, then we have top down assembly and the bottom up assembly. So let's go one by one. First of all, here you can see I have an assembly, and you can see two parts in here. So if I go up till, like, this is the part 4 and this is part 5, and from the sketch in here, you can see this is our part having dimensions, and we can control it with the help of dimensions. And then I am closing this part and moving towards the second part and opening it. And here from this arrow, you can see it is dependent on somewhere else. If I open the sketch, you can see there is no dimensions and it is from the reference. This icon shows that it is converted from some other edges. So what I did here, let me go back to assembly. What I did here, I let me press this part first, and from here you need to create a new assembly. In order to understand the top down assembly method, we need to first create an assembly, and then we need to create another part into it, and we need to select the part, and we need to select our plane on which we want to make constructions. And right here you need to draw the sketch and create your part. Whatever it is, I am keeping it simple and giving it the dimensions. It can be a complex part, but you can understand the approach. You are designing the first main part on which the rest of the assembly will be dependent. So I am extruding it and giving it a blind and click on OK. So here you can see I have my main part, which is called part 6, and the dimensions are, the 100 and the 50 mm. And on top of that, I will create one hole in the middle. Let me change the dimensions to 20 mm, maybe 10 mm, and I want it not to be in the middle. I will give the relation to here, I'm not giving the relation, I am giving the vertical relation, and then I am giving the dimension. So here I have the cutout through all like this. So this is my main part, and this is the first part. And now what I have to do, I have to go back, create a new part. And in for now, in the last part, I have selected from these planes of the assembly, but right now I want to create a part on top of it. What I will do, I will select this face from the top. I will move it normal, click on the surface and click on convert entities. Also, I will select this circle and click on convert entities. Now I can just simply extrude it, and 10 mm, click on OK and close the part. So here you can see I have created first part and the second part right here. And I will show you, if you want to make any modification, what you have to do is you need to just go down there into the first part, which is the reference part. We may rename it as well into the reference part. And I want to change the extrusion to 15 mm, and I want to change the position from 20 to 50. Sorry, it's the wrong dimension. I want to change it to 50, like here, and close it down. So here you can see I have made modification to my main part. And now I am going to close this part, click on yes. You can see my height has been changed and the position of the hole is also changed. And I have in mind that this hole should be with reference to this hole, so that we have aligned holes. So you can see in a top down assembly approach we have our part like this. So I am just changed the main reference part, the rest of the components have been changed. And other way to create this thing is we create a new part. I will click on the top. I will be creating a rectangle of the dimensions 100 and 50, and I am creating a circle in here, putting a relation horizontal and the dimensions as well. This is the same part. I have extruded it 10 mm and press OK. I will click on save and save the part in my location, and part will be part 8, and save this. And again I will create another part, create a top, because I want to align them up. So I will give the same dimensions. I will give the circle and the reference, put the dimensions. So this is the same, and I want to extrude it up 10 mm, and I will save it as a part 9 and save. And then I will create a new assembly, open it, and we'll select the two parts, part 8 and part 9. So the part 8 will be the fixed part, and the part 9 I will select these circles and apply the mates. I will select the bottom face and apply the mate, and I will select these faces and applies the mate. So here you can see we have these two assemblies. The first one, this one, and this is the same construction area right here, but these are not dependent on each other. If I want, this is basically called the bottom up assembly, in which we create the components of the assembly, and then we bring all those components into the assembly, and one by one we apply the mates. So the tip here, the crux here is that when we want to have a top up assembly, the other way around, moving towards the top down assembly, in this way our complex design can save a lot of time. But the critical point here is that your design intent should be clear to you, that which part will depend on which part and which feature. And that's why if you want in future to change something, you will just make modification to the first part, it will automatically be adjusted into the final part. For example, if I want to make it square, I can just simply change the dimension from my reference to the first part and close it up, and then just go back. Sorry, let me go back first. What was the issue here? Okay, this is some, I think, some rebuild issues. Okay, I want this to be in the middle, right? Like this. Maybe I could apply the relation like this. So I have modified the part, saved it. You can see the rest of the assembly automatically changed. But the same way you notice the error, right? And when I come back into the assembly, I saw the error into the second part. And this is very simple, and it took me some very little time to guess what was the issue, and I resolved it. But for example, if it is a very huge assembly with hundreds and two hundreds of parts, and you each depends on the reference part, you made some accidental change to the main part, rest of the components, all the components will get some error. And you will be blown away that how this happens. You will try to press Control Z to avoid that thing. So the top down assembly approach will cause this issue. So in order to avoid that, in some simple assemblies you need to focus on the bottom up assembly approach. So here, if you want to make some modifications into the first part like this, and we'll close it up, go back, you will see no changes into the second part. You will not see any issues in the second part. But you know that I have accidentally changed this part 9, but it must have to be aligned with this face. So what you will do, you will just open it again, you will go back to the assembly, you will measure this dimension, it's 100. Okay, I can go back and just give the dimension 100. You will see the issue has been resolved without any the practical without any facing any error. So in complex assemblies, this can this will not save your time obviously, but this can help you avoid a lot of issue that you will not know in bigger size assemblies, in which we have 150, 200, 250 parts. You will not know that I which part will have, I like we change which part of the design, and it will be in reference to what other functions of the other parts, what other features of the other parts. So to avoid that thing, you should use in your start of the career where you are not very aware, you are not very expert and good at SolidWorks. You need to just go to create the separate part. Once you have all those separate parts ready, you will just bring them up into the assembly and apply the mates and prepare your assembly. So this will really save your time in a way that in future if you accidentally make any modification, then you will not lose the whole project. You will just lose that specific part, but you can just delete that part and create that specific part again maybe, but the whole assembly will not get disturbed. But in top down assembly, if the main part is get got disturbed, the whole assembly will be destroyed, so you have to start from the very beginning. Right now, for example, I am going to add another part here just to understand the multi-body part. I'm going to add another part on the top, and I'm going to create convert this part. I'm going to extrude it up in the reverse direction to 20 maybe, like this one. So here you can see I have created another part. I need to edit this part and give a head of this as well. Maybe I can get this offset just and extrude it up 5 mm. Okay, so I have this part. For example, if you consider these two parts as plastic part and this is the third plastic part, and you want to get this assembled, in order to have, you know, the cross section first. Okay, so you will see all the parts are in contact face to face. Okay, so if you want to change the offset and make have should have some clearance in between these parts, so that it can when we manufacture it, it can easily get assembled. So what you can do is you can just go to the main part and change the diameter from here to 10 mm. I want to get the the offset, the maybe the tolerance, maybe the clearance of 0.5 mm. I will just specify 0.5 mm addition to make it a little bit bigger, so that we have the clearance between those parts. When I will save it up, you will see. Okay, so we are in the bottom up assembly, so this part is the main, not the main part. And we can consider our upper part as a main part. So if I want to change the gap between it, I just want to change this thing and add 0.5 mm of clearance and close it up, save and close back. So here you can see, if I will rebuild it, it must not, it must be changed. I don't know what's happening today. It have destroyed the relation. Let me again get back. I will delete this part. I will just have two components. I will edit the component here and give it the relation from here. So you can see I am not able to apply the relation like here, and here you can see close it up. Right, you can see I have now this part is dependent on the main part, part 9. So if I want to have the clearance in here, what I have to do is I will just simply change the main part. I want to change the main part, so that or maybe I want to have make change to this part as well. But considering that it is a complex assembly, we have the two parts, but it is a complex assembly. If I want to make the change and it has some mates, if I make it 11, little bit bigger, close it up, close it this down, you will see diameter of the second part is also 11. but I don't want to make change to this thing. So what you have to do, then you need to change this part as separate, remove this relation, make it independent, put the diameter of 10.5, so that you can have, but the relation is broken, so you need to again specify the concentric mate and close it up. Like here we got the clearance, but the issue is here, we have just two components, and it took me 4 to 5 changes to get up to this mark right here. And if I want, I will have to change a lot of components. I will go to the sketch, I will change the dimension, I will make the modification for each of the part. So at this stage, the multi-body part helps us. For example, let me create a new part. Multi-body usually create in in the part environment. I will create the same rectangle like this. I will give it the same dimensions. I will create the same circle and give it a dimension of 10 mm, give the relation as horizontal and the dimensions here as 20, and I am going to extrude it up 10 mm. Okay, this is the first thing. And I also want to create a bolt. I will simply the face, select it, convert it up, and I also want to create the head, so I will again convert this thing to 5 mm and click OK. So I will extrude from the contours. I will simply select the inner surface, rotate it up, move it 20 mm. And when we are going to create a multi-body, then we must uncheck this mark. If we select merge, it will create a single part. We need to create a multi-body, so we'll unmerge this, click on OK. Then I have to select this again circle, the bigger one. I have to extrude it 5 mm. And from here we want to merge the results, but we will select our selected bodies. So I want to merge this head with this thing, so I will select the body and click on OK. So now you can see we have two bodies in here, the first one and the second one. And this is ready for, we are supposing that this is ready for injection molding. But when we saw from the cross section view, you noticed that we don't have any clearances. But for the 3D printed part, but for the injection molding part, we must have to apply some clearance in here. So what we need to do, we will just simply go into the direct editing tools, click on the move face, click on the face, and give them the clearance value. I want to 0.5 mm offset, click on OK. And from here we will see the direction. Offset is outward, but we want it inwards, and click on OK. So you can see we have our two parts, the clearance is there. We have completely updated our part. We can just simply save these two bodies for the injection molding as a separate body. I have just changed, applied one feature, the part is ready for the injection molding. Similarly, if I want to change it to two, maybe, for example, if we have these two holes, and we do also have, I will give the offset, okay, close the sketch, and we have the two holes. And here, from here we can create two, I will select the other circle as well, click OK. And from this I will also select the other circle, merge results. Okay, so I will show you another tool. I have created these separate, you know you can see this is separate, and this is separate, these two are separate. But our first body, this one, is a single body. this one. So let me cross this up, and you can see this is a single body and these two are separate. So we need to search for a tool which is called combine tool, and when we work on multi-body parts, this tool is very handy. We will select these two and we will add them up. So we have these two, you know, the parts as separate part. This is the third part. So we can have 150 parts, or how many you can suppose. I will just move it down. I want that both of these parts should have some clearance. Okay, so one part, I want both of these should have clearance. So what I will do, I will just simply create a move face, and in this tab I will select all the faces that I want to have the clearance and click on OK. So just one tool, everything is cleared, right? So from here, if you want to get yeah, create you know, the bill of material, you need to you cannot able to create it in the part environment. So what you can do, you can just go into here and save those separate parts as well. You can insert into to new part, save the part as a separate name, maybe A first, save it. If you want to save it as a separate part but also linked with our part, the multi-body part environment, let me cancel it. Okay, so I will close this up. So if you want to link this part in when you insert it into a new part, in this way this part, this body will be linked with it. So in order, if in future you want to make any modification, for example, let me go back and open this part as well. It was in bottom up and I have called it A. You can see the diameter of this rod is 9 mm and this one is 20 diameter. If I want to change the diameter of these two, what I do, I will go back. We have extracted this body. I will just simply go in there, change the diameter from 5 to 6. Right now you can see we have 22 in our main multi-body part. When I click on save, I need to save multi-body. Okay, I need to save the part. Okay, when I click on my save and go back to my main part, you can see the diameter should be changed. So it have broken the reference. I need to close it down again. I have to first save the multi-body part and need to add it into the new part, name it as double A, save it and click on OK, and the unit should be yes. So here you can see we have the part linked with the main multi-body part. So the diameter is 22 mm. When I go back, I change the diameter to 5, and the diameter now you can see the 20 mm. When I go back, the diameter will be 20. So if you want to link this with the main body of the multi-body part, then you should use right click on the body, insert into part, into new part. You should use this tool. But if you want to just simply create the assembly and you don't care if it is linked or not, you can just simply right click here. You can create insert into new part, and you can simply create, sorry, you need to select these parts. Okay, right click and insert into new part, and you have to make the assembly. I am not getting, there is something missing today. I am missing some points here. Okay, yeah, consume cut bodies, create assembly from here. From this point you need to right click on here and save bodies. In order, if you want to create assembly from this, you need to click on save bodies, and you will click on auto assign if you want to auto assign the name. These are the name of the bodies, these will be auto assigned. But if you want to customize the names, you can just double click on it and save it as anyway a1 maybe, and save it. You can see a1 part, and I will select a2 and double click on it, and I will select a3 and save it up. So we have three bodies, and from here you can see create assembly option. You need to browse it and give it the location and the name of the file, multi body assembly, and I will save it up. And then, sorry, you don't need to check this box. Once you check this box, the name should be from the list that we have in our tree. So in order to have unique name, you need to select, double click, and assign the name. Let me give them again. Okay, so we have the assembly name already and the parts name. I will click on OK. I will save the units for all the three parts, rebuild it, and you can see we have our multi-body assembly. We have three components. All those, this arrow will indicate that these are linked with the main body, but this relation sometimes gets broken. So if in order to get you want them to be into the assembly for creating, the bill of materials, for creating the exploded views, you can just simply bring them in into the assembly right here. Okay, so this is how you can convert a multi-body part into assembly as well. So right here, when you create a part in multi-body assembly, it will help you to specify the clearances at the end of the at the end of the project. So right now you can see I can arrange my the tree into the folders. I can rename it and give it a name as the project features, and I can add the move face command into another folder by specifying clearances. So this is how you can see all those clearances are also applied, and the features are again on the same position. So if at any place you want to avoid these clearances, you can just drag this thing on the top. You will be into your main project file. So if you go down, it will be separate. So then for the creation of the BOM, you can just move it into the assembly and create an assembly from it. I will just go back to the slides, and we have covered the multi-body, the top-down assembly, and the bottom-up assembly. Moving towards some parametric and configurable design. So we will be using equations, configurations, and display states. I'm going to open it, and from this assembly I will guide you through how you can create new configurations. For example, if you want to create a configuration of this whole assembly in which you don't want to see some of the components, maybe you don't want to see these springs. So what you need to do is you can just simply open these components that you want to modify one by one. First one, I want to open this part, and then from the tree I will, here you can see, you will see this tree. You will go into the configuration manager and right click on the default configuration and create a, add a drive configuration from the default. This means you are going under this configuration. If I create one, you are going inside the main default configuration, and if you click on here, you can create a new configuration. I will name it as A1, and in the A1 configuration I will go back into the tree. I will select the features that I want to express, this one, and then at the end we have this revolve. I want to express them up. You can see I have expressed it up. I will just simply go there. Here we have A1, and here we have the main default configuration. I will save it and close this model. Similarly, I will go into the second, and here I will also create a new configuration. I will name it as A1 and go into the tree. I will select these features, revolve feature and this one. I will press them. I also don't want these text here. This extrude feature needs to be pressed. I also don't want these features. I will really want to clean it up. So here you can see we have our clean model, and we are into our A1 configurations, and I will click on Control S and Control W to save the model, close the model. So these two have been changed. I will just go into this main part as well. I want to create a hole at this location as well. First of all, we need to create a configuration, and the configuration name will be the same as A1. I will select the face, create a circle, and I will just simply cut it up. I can just simply link to the thickness and close it up. So here you can see I can maybe apply the fillets as well. And in we are in A1 configuration. I will press Control S and Control W. So we have three changes, and right now I will change the handle, the fourth one as well. Add the configuration. I'm repeating for all the components just because you may follow me throughout. A1 configuration, I will go back, select this extrusion. I will increase the length. It's 0.25. I will create 0.35, maybe 0.5, and press OK. So here the length have been changed. Again, go back there. From here 0.5, and from this you can see we have this configuration, all configuration and specify configuration. So we were in our main configuration that we want to make changes in. So we will go back, edit the feature, and we will select this configuration, and I will press OK. So you can see we have changed it for the current configuration and saved it up. Now what we have to do, we have to create another configuration into the assembly for the new assembly that we want. I will select on add configurations. I will name it as A1 assembly, and now one by one I will click on the part, select A1, click OK. I will go back. Let me show you what was the issue here. When I was in this feature, I was selecting all configurations and just saved it. So that's why it got saved in this configuration as well. So what you have to do, you need to edit this feature in the main assembly as well and convert it into this configuration and click OK. And then go back into the feature. We need to change it to the main dimensions what we have at the initial stage. Then go back to the A1, and here you can see we have changed this dimension and also selected this configuration. So this is only changing in the current configuration. I will save it up, and here if I select default, you can see we have our main default. So I will change it to A1, select OK. I will select this as well. I will change it to A1, click OK. You have see the hole here. I will change this to A1 as well. I will also change this to A1 and OK. So you can see we have our new clean assembly, and our main assembly is already there just as before. And moving towards the display state, you can see at the bottom We have, this is the main display state. What I will do, I will just select all of these, hide them up. I want to see just this angle. And once I have this, I will right click, add display state, and I will rename it to sheet metal part. So unfortunately it crashes away. Let me open it up again. I think you have get the point. Okay, so we are back, and let me get back to that stage that we were at. I think yeah, we have studied the configurations. We are now working on the display states. So this is our main display state, and what I will do, I will create a new display state. Add display state. I will rename this to maybe handle. And once we have the handle, I will select the part. I can manually hide them, or maybe I will just keep my cursor on the part and press on the tab from the keyboard. So you can see we have our handle like here. And I will go back to my main, and I will create, add a display state. I will change it to sheet metal bracket. And then what I will do, I will just hide the rest of the components. So this is how you can see we have our sheet metal part, we have our handle like here. Once we are done with it, we have our main assembly, we have our this sheet metal bracket, we have our handle here. So these display states can help you create the assembly, and also the separate parts from this same assembly when you create the drawing views. So moving towards our next stage, which is using equations. I'm going to close this and open a new part. In here we need to just simply create a new sketch. I will apply the dimensions like this. I want to create a rectangular box with the lid on the top as well. I will create a rectangle, specify the dimensions. It's I will, what I have to do, I maybe in future I have to change the length of the box, the width of the box, and maybe the height of the box. What I will do, while specifying the width of the box, I will select the dimensions. I will click on W and press on OK, and create a new global variable name W, which means width. I will say yes, and now I will specify the dimensions. Sorry, it haven't created yet, but you can see W as 105 from here. Once you have this thing, you can just simply like I have explained in the previous, when you created a new part, you haven't seen the questions tab in here. So to get the questions tab, you can simply just create this thing from there. And also you can open from the search tab as well. So I usually do in this way, that by giving the dimensions. And from here I can just simply double click, press on equal, as global variable will be W as a width, and click on OK. So we have the W width. We need to go to the sketch. We need to provide the second dimensions equal to width and the length, and I will click on OK. global variable created, and I will specify the dimension to 200 and press OK and click on OK. So when we go back into the question, we can see the width and the length. And now I will create an offset from here for the wall thickness. So what I will do, I will just simply click on the rectangle. I will click on offset. I want it to be ready for injection molding. So the 3 mm is the maximum wall thickness. So I will click on the 3 and press OK. So here you can see we have the offset value as well. So what I will do, I will double click on it, press equal, press wall. I will simply say the wall and click on OK, press enter. I will create simple variable called as wall and the dimension will be 3. I will press OK. So from the tree you can see we have width, length and the wall as well. And now I will extrude it up, give it the height of 20 mm, and simply click on OK. And another thing there, if we want to specify the height as well, we can just simply click on equal h for the variable, create the variable, specify the dimension of 20 mm and press on OK. So we have all those width, length and the height. And if later on we want to modify, maybe for example, if you want to add another other feature, for example you have to create, let's first close it up from the bottom. I will just simply convert it and extrude it to what, to the wall thickness. So I will click on equal, from the global variables I will select wall and press OK. So we have the 3 mm thickness in there as uniform thickness. So if I want to create compartments in between, what I will do, I will simply go and create some sections here. I will select it as a half. I will select this thing and divide it into half. So these are the walls. What I will do, I will select features, extrude it up. So in the one direction I will specify equal, and from the global variables I will select wall and press OK. Let me change the extrusion in the reverse blind, and I will create in the reverse direction up to surface, from this surface and OK. So now you can see we have our components. These are separate bodies, so I have to select the merge face as well. So here you can see what I want to make sure make you learn from this thing is that once you are going to prepare a part for the injection molding, and your client or maybe your instructor wants this thing to be in a bigger size. Right now we have this as let me give the dimensions to it. It's 105, but I want to change the dimension. I will just double click, right click, manage, and from there I will change it to 100. So right now we have our 100 by 200 mm. This one is 106 and this one is 206, but our instructor wants to have the double size of this thing. So what we will do, we will just simply, but one thing that you can do, you can double the size with the help of scale command. You will select the body, and from this, change it to origin. You can just simply double it and click on OK. You can see we have our double model. The size will be the double, 212, 106, and 4012 of 206. But you will see, you will notice exactly the wall thickness have been changed to 6 mm, but this part is not ready for the injection molding. So for a very complex design, if your instructor wants the design to be in a bigger size, but you must ensure that the wall thickness still remains 3 mm, so you will struggle in there. So you will say that you can use the direct editing tool. You can just remove the select the edges and remove these 3 mm space to make it, sorry, so you can remove the 3 mm face from here. In the reverse direction, you will select all those faces like this. Let me close it up. You can see the wall thickness is 3, but you will notice some other issues as well. Let me change, unselect this face. Right, we have changed the dimension, but you will see this is a very simple model. So you can use a move face and change the wall thickness uniformly. But if I go back, I want to upscale this thing. I will just simply change the diameter, sorry, the width. I will make it 200. I will make it 400, and I will maybe double the height as well to 40. I will change the 3 dimensions, press on OK. You will see we have our design changed to the big double size, but the wall thickness is still the same, 3 mm. And maybe in future, if your instructor wants the wall thickness should be 6 mm, we will not injection mold, we will use it to manufacture with the help of 3D printer. So you will just go in there and simply change the wall thickness to 6 mm and click on OK. So you will see everything has been changed. So how much complex your design will be once you have those equations here for the major dimensions that you think in future we might have to change. You should use with the help of the equations. At the very first stage, you should provide the width, the length, heights. Maybe you should provide the rib thickness. You can just go to the managed equations. You can type in here as rib rib thickness. You can give them the value of 1 mm and click on OK. So in order, if you want to create the rib thickness, all you need to do is, for example, if we consider this thing as rib, we can just simply go in there, change the variable from wall to rib thickness and click on OK. So you can see the rib thickness has been automatically adjusted. So the wall thickness is still the same, and your in the complex design, then where you have a lot of ribs, if you want to change the rib thickness, you will just go in the table and change it to 2 mm and click on OK. So everything will be automatically adjusted. If you want to change the wall thickness, you will just go in there and change it to 10 mm and press OK. So you can see only the wall thickness have been changed. You will also notice that the bottom face is also changing to 10 mm because we have selected this as wall. So this is the design intent. Basically, I knew what I have to change in future, so I have put that thing in the equations tab. So this is also a parametric modeling. So one thing we can do, we can also use table for that thing, but that is a little bit complex to cover it in one session. So you can explore that thing in from the YouTube, how to create models with the help of tables, design tables. So in that you will use Excel to increase the dimensions in whatever way you want to change them. So this is how we use equations. So moving towards our next thing, we have some career opportunities. Before going into career opportunity, let me go back to one of the slide, and here I have some reference documents. I have not attached all the concepts, and all I have not also added the values, like what should be the rib size, the standard rib size, what should be the dimensions for the drafts, what should be the wall thicknesses. Everything is written in a document I have, and you don't need to remember them, but you should have that with you while you are designing the part for ready for the injection molding. So make sure to fill the feedback form at the end of this presentation, so that I will get your email, and then I will send those reference documents for injection molding, for 3D printing, and some other resources to all the participants. From them, those who will fill the feedback form, and I will get their email, so that I can send them out through the email. So back to the career opportunities for SolidWorks. So first thing first, a lot of you will knew that you can give services through Upwork, Guru, Freelancer, and even though through LinkedIn as well, once you have been basically very good at SolidWorks, not SolidWorks, but the design softwares. But SolidWorks plays an important role because it provides the service certifications that are proof of your skill set, so you can sell them and through the marketplaces out there like Upwork, Guru, freelancers. So provide the services of CAD design, product design and development, even though the production as well. Moving towards the selling designs, you can sell the design with the help of your own websites, and we have some other platform like Sketchfab, 3D Export, Etsy. You can just create your own custom design. Maybe you can utilize your creativity to create a new model that is not already in the market, just maybe a decor piece. You can just upload it onto the Sketchfab, CG Trader, Etsy, and the people will buy the digital models from you. So you can sell those, and this is a passive income source. You have to put your effort for the one time only, but the earning from that model will be continued till then the model is on the platform. So this is a great opportunity for the creative 3D designers to sell their models, their custom models. And you can also even do follow the trend, that like what's trending nowadays. You can create the model for that. Maybe for example, a football cup, when we have any champions trophy, then you can just simply create the trophy for that and upload that. Maybe in that season people will buy the trophy and to 3D print it, maybe the STL files, maybe the CAD files. And on Etsy you have the option to sell your physical models as well. You can have your printer and sell print them up and sell the physical models, so you can have a better profit margin from there. Moving toward product design and prototyping services, this is what we have discussed at the very first slide, from the sketching towards the final market ready product. So you can, like, you have those areas, the sketching in your hand, you can learn that. You have the CAD modeling skill set, you can procure the things, and finally you can outsource the thing if you do not have your own, you know any manufacturing facility. Then you can just outsource them to a manufacturer, print from them, and sell it on your behalf, because you are the one who is procuring the services for your customer, for your client. So you can, from the at the initial stage, you can outsource that. And once you are ready to establish, and even though you can ready to buy your own 3D printer, then you can give the at least you can give prototyping services with the help of your own 3D printer. So from the design till the prototyping stage, you can provide services, and these are highly paying in the market. And also, even though if you don't have any projects, any stuff like this, but you are good at SolidWorks, you can create tutorials on SolidWorks. This that will help you up in like getting the social recognition, and in the term of earnings as well. YouTube can give you earnings, and also you could create your short courses on Udemy, Coursera, and even though you can bid on the projects on Upwork for giving consultations and giving the teaching opportunities to the students, that you will teach them the use of the design tool, and you will teach them how to uh, excel in your field. So this is not related to SolidWorks only, but you can sell anything, you can teach anything, you can give consultation in your field. Maybe it's mechanical, maybe it's out of mechanical, but you can give everything as a consultation and a teaching stuff on many digital platforms. So this is an earning source for you as well. So before going into the Q&A and the feedback form, first of all, uh, I will recommend one thing from my experience, that the tool itself is not really difficult. For example, SolidWorks is not really difficult. You can learn that. You can if someone don't have a degree, then he can also learn SolidWorks by following the tutorials, because there is a lot of stuff available on the YouTube. But the important thing that we discussed in today's presentation was the design intent, the thinking, that how you can understand the requirements of the client, the knowledge that you can give to your client to impress them and to get the project. And these are the things that help you stand out in the market. So the design intent saves you a lot of time. The automation, just like the configurations, the usage of equations, the usage of reference geometries, just like in the top down assemblies. If you are really good at that, that will save a lot of time. So if you are really good at top down assemblies, and if you are really good at the multi-body part, then that will be an amazing thing for you, because that will save a lot of time. And in today's era, people want everything in a quick manner. Like, they have an idea today, they want you to prepare the CAD model for till tomorrow, so that they can get that idea visualized in the form of ready to manufacture 3D printed part. So you have to be quick in your designs. For that, you have to be have a strong imaginations. So that's why I will recommend you to for not go to on the SolidWorks screen before you have a clear idea and an image of the CAD in your mind only. You don't have to open SolidWorks. Once you have the design and the design intent in your mind, that this is how you are going to approach the model, then you can just simply go to the SolidWorks and implement those changes, and you will get it in a very quick fashion. So this is my recommendation for you guys, because what helped me in freelancing to become a top rated, and in near future, maybe in a 1 month, I will be top rated plus. And I am from zero to top rated plus, it took me around 1.4 or 1.5 months to come at this stage. The only difference, I am not very good at SolidWorks, but what I am good at is the design intent, and the way that I get understanding of my client, and I help them understand their ideas even better than they know that idea. So you have to prepare yourself according to this mindset, not to be expert on the SolidWorks, but to be expert on unwrapping the ideas from the client and having a perfect design intent to model the project in a very fast fashion. So this is it pretty much for today. And you have the feedback form on the left, and maybe you have noticed some flaws in today's presentation. I would love to hear back that thing in the feedback form, so that in the next section, your recommendations will help me to even stand out for the next sessions. So I request you to please scan this QR code and fill the feedback form, and I will share you the reference documents to you on the email. So thank you so much for today's session, and the platform is over to you, Yusuf.
Thank you so much, Ali, for your amazing session. You really broke down some advanced topics in a simple and practical way. I think everyone has here picked something valuable from your project and experience. It's always
Thank you.
inspiring to learn from something with real industry experience. And
Yeah,
we
thank you so
really,
much.
really appreciate your sharing your time and knowledge with us today. Before we wrap up everything, we would love to open the floor for Q&A if you have a couple of minutes, extra couple of minutes.
Yeah, yeah, you can ask me anything.
If someone have any questions before we wrap up the session, you can ask Engineer علي. لو حد عنده أي أسئلة يقدر يتفضل دلوقتي وباشمهندس علي يجاوب عليه.
So anyone have any questions, please?
Okay, until then, the session is recorded. I will upload it into a drive and send it to you. Okay, send feedback. I will upload the session and send the link with you. Until that, anyone has any question, please ask. Okay, until you watch the record again, if you have any question regarding the swagging, contact me. Regarding the session, you can contact Engineer Ali. He is a very, very talented person. I want all of you to uh, understand this session well. And if you have any question, let's contact us. Okay. So as no one have any question, thank you again, Engineer Ali, for your fantastic and wonderful session. It's a great pleasure to have you today with us, and thank you a lot.
Thank you so much, Ahmed, Muhammad, and thank you so much, Yusuf, for being with me today. And I'm really enjoyed the time here with you guys. And if any of the attendees or anyone need any sort of help, they may reach me on the LinkedIn, and you can also contact me through my email. You can also contact me through the LinkedIn. So thank you so much again for this valuable time from for attending the session, and also for Mansoura SolidWorks user group to invite me here today. So for that thing that if the form is saying that you have already responded, I'm going to change the settings for the form, and I will once the settings have been changed, I will share it on the LinkedIn as well, and also with Ahmed, to be shared with you guys. Thank you so much again, and that's pretty much it. So we should wrap it up.
Sure. Thank you. Now we finish everything. If, if, uh, if there is some question, you can type it in the chat. If no, you can leave the meeting and get ready for the uh, s- next session next week. Okay, and thank you all.
So we don't have any questions. So until the next session in the near future, take care and goodbye.
Goodbye.